Good morning, this is Miss Billerbeck and we're going to talk about slope-intercept form. This is one of the most popular forms to use for equations, so it's a good thing to get to know this one quite well. So let's do a real-life example of it. So we have Doug wanted to buy a cutthroat bike, a cutthroat ride the divide gravel bike for $2,700. He could make a down payment of $1,500 and make 6 equal payments, or pay no down payment and make 9 equal payments. To what does that amount? So let's take a look at, well, what would this look like? So if we were to write or to draw the graph, so we have y and x. Okay, we know the cutthroat bike is $2,700. Okay, so we need to pay that much off. So if we count this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to divide that 2,700 by 10, which means that each one of these spaces is going to be 270. So we have 270. The next one would be 540. Okay, let's double it up. So that's adding 270. Let's add 540 again. So we have 1,080. Then add 540 to that. So that gives us 1,620. Then add 540 to that. We have 2,160. And then this top one will be 2,700. So we have the amount up there. Okay, so we want to pay that amount by 9 months. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we don't need to use all these spaces, but we can do 2, 4, 6, 8, 10, 12, and call it that. So these are going to be the payments that we make. And these are the dollars we need to pay. So we should understand what these are. Okay, so for option 1, we pay $1,500. So $1,500 is about here. And then in 6 payments, we want to be at $2,700. So at 6 payments, that gets us here. So you only need 2 points to make a line. And so we have our 2 points at 1,500. And at 6 payments, we should be done with $2,700. So this is what it should look like. Okay. So if we were to graph it, and then we could go back and estimate, well, how much is that? So right here is payment 1, payment 2, payment 3, payment 4, and payment 5, and payment 6. So we can see, well, that's about $1,700. It's about $1,900. That's about $2,100. 2,300, and then the net last one before we pay it off is 2,500, and then 2,700. So that makes complete sense. So now the other option is that we don't pay anything down. So we start here, but we pay it off in 9 months. So we have our 2 points. And we draw the line. And we can tell what our payments are for each month on this one. So payment 1, payment 2, payment 3, payment 4, payment 5, 6, 7, 8, 9. So payment 1 That's about 300, 600, 900, 1200, 1500. So it's about the same as this one, should be. 1800, 2100, 2400, and 2700. So it matches up perfectly with the graph. But there's another way we could have done this, and that's using the slope-intercept form. So we have the $2,700 that we owe. And we want to pay it off in 9 payments, so 9 times the payments plus 0 down. Okay, or we could do $2,700 equals 6 payments plus 1,500 down. Okay, so we have 2 ways of doing it. Now, if we substitute P in for payments, that would give us $2,700 equals 9P. And we could quickly solve for how many payments we're going to be making, or the amount of payments, the dollar amount. So we divide by 9, and that gives us $300 payments if we have nothing down. On this one, we would subtract the 1,500 from both sides. And that gives us $1,200 equals 6P. And then we divide by 6. So this payment option would have been $200 for the bike. So we're using a slope. The slope for this one is 9. Okay. And this slope here is 6, so the 6P. So let's write those 2 equations. So if we didn't know what this was, if we said this was y, this equals 9, and instead of payments, let's use x plus 0. So this one is y equals 9x plus 0, which we really don't need the plus 0. Okay, now let's say this one's y equals 6x plus 1,500. So this would be y equals 6x plus 1,500. So that would be your slope-intercept form of the equation for this problem, a real-life problem. Now you're probably going, this is a lot to think about. Well, let's break it down into smaller chunks, so maybe it's a little easier to understand. So what is slope-intercept form to start? Okay, so slope-intercept form, if I have a line like this, and then I have a rise and a run. If I make this little triangle, it's going to be the same little triangle no matter what I make. And if it goes under, it goes under. So see how it can just go under here and be the same triangle. It's just flipped around. So the rise for this one is 1, and the run of this one's a positive 2. So positive 1 is up, negative 1 would be down. So for this one, it would be a negative 1 rise, negative run 2 is a negative 2 run. So right here, this slope triangle, negative 1 over negative 2 is still 1/2. Okay, this triangle here is a rise of 1 and a run of 2, 1/2. So it doesn't matter which way we go, if our negatives will cancel each other out if there's 2. So if it's a positive slope, and if it's a negative slope, that one negative will always carry through. So the y-intercept is that down payment we were talking about on the bike. It's that one-time payment. It's where it hits this y-axis. Okay, it's called a y-intercept. So if you think of it like football, and that player's out there running, and where the player actually catches the ball or intercepts the ball. So think about the y-axis catching the line. All right, so, and then our slope-intercept form of the equation is y equals mx plus b. So where m is the slope and y is the y-intercept. Okay, so you probably know m, or slope, as rise over run. In calculus, you'll learn that it's delta y over delta x. And then delta y over delta x in lower mathematical language is y2 minus y1 over x2 minus x1. So you're going to learn it this way, and later on you're going to be able to see these things as delta y, meaning the change of y, and the change of x. Okay, so that's where you're going with this. All right, so here's another way to look at slope-intercept before we start getting into problems. Okay, so we have a linear function. Linear means it makes a line. So it can be written in slope-intercept form with m and b as constants. Okay, so y equals mx plus b. This is how it changes. You know, we're paying 6 payments, 6 for each month. So we're changing the number of the month and times the payments in that last problem. And that's how it starts. You know, did you do pay a down payment? Did you make a membership fee, a one-time membership fee? So this would be a one-time deal. This is a reoccurring deal where you might see each week, each month, per. There's some keywords that would trigger, oh, that's a slope. Okay, so a slope is rise over run or rate of change. This got a little messed up over the years, but that's rate of change. And then y-intercept, where it hits the y-axis, which is the coordinate is 0b, the back. Okay, so let's do a problem now. Finally, let's talk more action there. Okay, so we're going to graph y equals 4/5 x plus 2, and then we're going to graph this one. So remember how I said the y-intercept's how it starts? So that's the first point we're going to plot. So that's at 2. Now from this point, the y-intercept, we are going to rise 4. So this one says the slope m is 4 over 5, which is the rise over the run. So I like fractional slopes. So I'm going to rise 4, and each one of these is 1. So I can just count 1, 2, 3, 4, and run 5. 1, 2, 3, 4, 5. And that's my second point. I only need 2 points for a line, so I'm done. Unless I'm feeling uncomfortable with my decision, then I can find another point. Okay, so let's draw that. So we have line 1. Now, if we did that right, we could drop -4, 1, 2, 3, 4, and run -5, 1, 2, 3, 4, 5. And it lines up too. So we actually have 3 points, and those are going to go on forever there. So we're going to make arrows. Okay, this one here, our slope, is -3 over 4. Now the negative could go with the 3, or the negative could go with a 4 for the rise of the run. But we're going to start our line here at -5. So it starts at -5. Now we're going to rise 3, 1, 2, 3, and run 4. 1, 2, 3, 4. So our other point would be here. Okay, we could have risen -3, 1, 2, 3, and run +4, 1, 2, 3, 4. Then you notice they're all in the same line. So, so we don't worry about, is it going to be m equals -3/4, or is it 3/-4? You can do it either way when you're rising and running with a negative. Okay, so when we draw this line, it looks like this. All right, so we can quickly test the points as well. So this says that this point, or -8, is on that line. So if we put in 4, that makes it -3, and -3 plus -5 is -8. Now this one here, this coordinate's 5, 6. If I put in a 5 here, I have 4 plus 2 is 6, because the 5/5 is cancels and it's 1. Okay, so that's a quick way to check, did I graph this correctly? Now the other thing I wanted you to see is one of these slopes is a positive. So with a positive slope, as I increase my x, my y should increase. With a negative slope, as I decrease x, as I increase x, my y should decrease. Okay, if I'm decreasing x, my y should increase. But usually we say as x increases, y decreases. And that's a negative slope. So you should just be able to look at the line and know, is this a positive slope or a negative slope when you're looking at it, with no other indication, okay? All right, with that in mind, is this a positive or a negative slope? As x increases, y is increasing. So what are we dealing with? It is a positive slope. So now we look hard and see, oh, it's starting here. So we know one key ingredient here. We don't know this one yet, but we do know that it starts at -2. So we're going to put a -2 because we have y equals mx plus b. Well, b is -2. So we are going to start it right there. Okay, now we do a rise run. So we're rising 1, running, running 2. Rising 1, running 2. Okay, so we have a rise of 1, running of 2. It's just that easy. Can you believe it? Okay, so let's double check and see. Well, this point here that we were given is 4, 0. So if I put 4 in here, half of 4 is 2. 2 minus 2 is 0. It checks. Okay, so that's how you check to see, did you make the right equation? All right, so what is the equation of a line that passes through points 5, 4, and -1, 6, and write in slope-intercept form? Okay, well, let's look at what was just given to us. So we have an x1 and a y1, and this one is an x2 and a y2. Now it doesn't matter, this could have been x2, y2, and that could have been x1, y1, and I'll show you why. Okay, so we have the slope. And the slope's formula again is y2 minus y1 over x2 minus x1. Now, the key thing is to keep your 1-point coordinates over itself. Okay, so what that means is y2 is 6 and y1 is 4. So we want the y's on top. x2 is -1 minus the x1 is 5. So what that's going to give us is 2 over -6, which is -1/3 for our slope. Okay, now if we did this the other way, if we said, hey, this is 0.2 and that's 0.1, then I would have had 4 minus 6 over 5 minus a -1, which gave me -2 over 6, which is -1/3. Okay, so are we going to get nervous about which point we're going to name 0.1 or 0.2? Absolutely not. And we're going to get the same slope no matter which point we choose. Okay, so let's make some room here. Now we have our slope. So we also have an x and a y, so we can choose whatever one we want. Let's choose the one without negatives because negatives can cause some issues. So if this is my y, I can put that y value in here. My slope is -1/3, and my x is 5 plus b. So that gives me 4 equals -5/3 plus b. I see I'm going to have to make this a 3 over 3 here. So I'm going to have 12 over thirds equals -5/3 plus b. That's a b, not a 5. Okay, and then I'm going to subtract this 5, add 5/3 to both sides. Okay, I could probably add it better over here, so I'll do that. So I'll add 5/3 here. So these cancel, and then when I add that together, I get b equals, and then I have 17/3, so that would be 5 2/3. So my equation then, I probably want to keep it as a fraction, so my equation then would be y equals, and I have -1/3 x plus 17/3. Now if that works pretty well, when I put in these points, I should get that. So let's test it out with the other point that we didn't use. We used 4, 5. So if this is my equation of the line, I'm going to plug that in. So 6 equals -1/3 times -1 plus 17 over 3. So we have 6 equals, that becomes a +1/3 plus 17 gives me 18/3, and that equals 6. So that's a check. We've got an equation, even though it looks like a pretty nasty little equation there, it is the right equation for those 2 points. All right, now let's look at another problem. Okay, so we have a gift card here in dollars. Okay, and these are 2 points. So someone was using their gift card when they bought the second medium cup of coffee. Wow, that's a lot of E's right there. Second cup of coffee. It was they had $19.70 on their gift card. When they bought the fourth cup of coffee, they had $14.40 on the gift card. So what we need to know is Well, what was the original value of the gift card? Okay, so we could do this a simple way. We could just draw a line, because 2 points make a line. So let's try that, actually. Okay, so if we draw the line, whoops. Okay, so we see if we draw a line, whoop, we missed it a little bit here, so our line might not be perfect. So let's use the math, because it says somewhere around 9 cups of coffee. We're going to be done with this, and it's around a little above 24. So let's figure out, well, what is this y-intercept? So we're given these 2 points, so we can get the slope from these 2 points. So m equals, and again, it doesn't matter which one you start with. I think decimals are a little easier to do with a higher one first when you're subtracting, and then 2 minus 4 on the bottom. So remember, you have to keep the point together. So this is 0.2197. 4 goes with the 14.4. So this gives us, let's see, that's 5.3 over -2. Okay, so our slope then, if we divide that by 2, it's going to be a negative slope. And that, let's do a quick division here. So 2 into 5.3 gives us 2, 6, 5. So we get -265 for our slope. So each cup of coffee then is $2.65 apparently. So we have our slope. So then what we can do is say, okay, what is the y-intercept? So we do have one of these points, so let's figure that out. We have 19.7 equals the -2.65, and we have an x, that is 2, plus b, and that's a b, not a 6. Don't know why I keep making it a 6. Okay, so we have a plus b, and then 2 times $2.65. Well, so we're going to 2 times 650, $6, 2 times $1.65. Whew. Okay, so we have 32, 13. Oh, I'm doing 5. Let's do 2 and do it the way it says. Okay, so 2 times 5 is 10. Then we have 12. So that's $5.20. So we add that because this is negative. So we're adding $5.20 to both sides. We line up our decimals. So that should be $5.30. There we go. I forgot to carry that. Okay, so then we have 10, 25. So we just found it. So that's 0, and that's b. So we just found our b. So our equation then is y equals -$2.65 per cup of coffee, and we started out with a $25 gift card. Okay, so that's how you would make an equation from that. So this value right here is $25. All right, so then how many medium copies can be bought? Okay, so that means we want y to be 0, because see right here, that's 0. So where it hits the y-axis, y has to be 0. So we have 0 equals negative $2.65 times x plus 25. Okay, so we subtract the 25 from both sides. So that gives us negative 25 equals negative 265x. And then we're going to divide by the negative 265 using a multiplicative inverse. And so what is this value of x? So when we figure out what is 25 divided by 2.65, we get 9.43 cups. So we can buy 9.43 cups of coffee. Wait a second, can we buy 9.43 cups of coffee? No, we cannot. They would laugh at us, wouldn't they? We can only buy 1 coffee, 2 coffee, 3 coffee, 4 coffees, 5 coffees, 6 coffees. So we can buy 9 coffees. Because we can't buy partial coffees, okay? So that's how many coffees we can buy with a gift card. And then this 43 cents we can give to charity or something, okay? So at the coffee shop charity, okay? So that's it for this lesson. I hope you learned a lot about slope-intercept form. Have a wonderful day. Bye-bye.